Hey Geometry, new video for you guys over lesson 7.1. This is all about quadrilaterals, which are four-sided figures, and we can pretty much break up the special quadrilaterals we'll talk about in two different camps. One in which you've got the parallelogram camp, which has a few others, and then the other one are kind of like the leftovers, the kites, the trapezoids, and the isosceles trapezoids. So without any further ado, let's talk about the parallelograms. So, what's the thing with the parallelogram? Well, it's a quadrilateral that has both pairs of opposite sides being parallel. So, this side and this side are parallel to one another. This side and this side are parallel to one another. So, I'm not going to write anything more beyond that. It's just two pairs of opposite parallel sides. Two pairs of opposite parallel sides. And they generally look like this. Okay. Now, a rhombus is a specific type of parallelogram. It's a specific type of parallelogram in which all four sides are congruent. So if you look over at the document here, it's still got two sets of opposite parallel lines. So these two lines are parallel to one another. These two lines are parallel to one another. It's just all four sides are the same. Think of it like a square that's been stepped on and scrunched, kind of. Right, okay. So we've got a parallelogram, and under a parallelogram, you've got a specific type called a rhombus. Some people like to call it a diamond, but a diamond really is a three-dimensional figure. Like a diamond is a thing. You know what? We're not going to get into that discussion right now. Third type, a rectangle. This is a specific type of parallelogram, once again. A specific type of parallelogram and over here it says it's got four right angles. With four right angles. And I think you guys know what a rectangle looks like, but maybe you've just never considered it in that way before. Here's a good picture to show you guys. Four right angles here. Okay. But again, the big thing is it is a parallelogram. And then lastly, a square is a specific type of parallelogram that also carries rhombus properties, so all four sides are the same, and rectangle properties. All the angles are 90 degrees. So a square has four, sorry, that's a really terrible looking square. Four 90-degree angles, four equal sides. So a square is not only a parallelogram. A square is not only a parallelogram, but a square is a rhombus and a rectangle. So, you know what? Think about it maybe like this. Think about the parallelogram is sort of like a broad generalization of somebody. So maybe parallelogram, let's talk football. A football player, all right? Rhombus could be something like, I don't know, a specific type of football player. Maybe we're talking about a linebacker. A rectangle is also a specific type of football player, but it's different from a rhombus. So maybe this is sort of like a receiver of some kind. But the square is not only a football player, but it's a linebacker who also happens to be a receiver. Okay, maybe my football metaphor breaks down right there, but you get the idea. The square can also be written as a rectangle, rhombus, or parallelogram. Okay, I know, that's a lot of info right now, and I'm about to show you some more. So those fit in a nice, neat family. These are the quadrilaterals that really resist the properties of parallelograms. For instance, a kite looks like this. It has two pairs of adjacent sides that are congruent, so these would be called adjacent sides. There's one pair of congruent adjacent sides. Here's a second pair of congruent adjacent sides, but none of the opposite sides are congruent, okay? If the opposite sides were congruent, then it would be a rhombus, but it's not. So the big part about the kite is there are no parallel lines. There's no pairs of parallel lines. You've got two side-by-side congruents and two side-by-side congruent sides here. Okay? And that's all I'm going to say about the kite at this point. Now a trapezoid pretty much just means it isn't quite a parallelogram. It has one pair of opposite parallel lines. So, one pair of opposite parallel, I guess we should call them sides. Sides. So all we need for a trapezoid to exist is, say, these two sides are parallel. These right here aren't. So as long as we've got this going on, we've got a trapezoid, with those little arrows meaning these two sides are parallel to one another. Yeah. And then within the trapezoid family is an isosceles trapezoid. The only thing different about an isosceles trapezoid is that these two legs right here, you call these the legs of the trapezoids, they're congruent. Now, this is the normal picture that you guys probably remember seeing trapezoids as. These are parallel, and these are parallel. So, what kind of things am I going to ask you guys to do as you work with these definitions for quadrilaterals? That's a great question. Well, what I might ask you guys to do is use your understanding of things prior to this lesson, like the distance formula, to make... I want you guys to be able to take information like you see here and be able to classify the quadrilaterals, but then also going back to saying, hey, do we know how to actually work with these ordered pairs? Here, watch this. I'm working from check your understanding number 2. Now what they gave us here are 4 ordered pairs, which represent 4 points on a quadrilateral. So -3, 3 would be this point here. There's A. B would be 2, 4. There's B. C would be 3, -1. And D would be -2, -2. So they're saying, what kind of quadrilateral is this? So what we need to be able to do is to say, hey, what are the side lengths? And are these parallel to one another? So the question is, what do you do for side length? Well, it's the distance between 2 points. You'd use the distance formula. So when I plug all these coordinates into the distance formula, I get that each of these sides is root 26. I'm not going to go through all that in the notes. If you need help with a distance formula, the distance between 2 points, I would suggest plugging that into a YouTube search engine just to figure out how do I find the distance between A and B. I'll leave that up to you guys. But bottom line is they all came out to be the same. Great. So the most precise name for this quadrilateral is it's either a rhombus or maybe it's a square if these meet at 90 degrees. So this is more of a question of maybe parallel versus perpendicular. Perpendicular line segments meet at 90 degrees. So the question is, if I know the slope of AB, I can compare that to the slope of BC and perhaps figure out, hey, is this 90 degrees? Is it not 90 degrees? And here's what you do. You can count the rise over run for AB to find its slope. So if you went up 1 and then right 1, 2, 3, 4, 5, AB's slope is 1/5. BC's slope is down 4, 5, right 1. It's -5/1. And if you recall, back in this first semester, we talked about perpendicular lines are negative flips of one another. We called them negative reciprocals. Because these two are negative reciprocals, they do meet at 90 degrees. Okay? And then you do the exact same thing. You compare the slope of DC, which again is 1/5, which means it is perpendicular to the -5/1. And then look at AD, which is down 5, right 1 again. So they all turn out to be 90 degrees. So you can say definitively that this is a square. It's a lot of work, but what we're doing is we're saying, look, you can maybe memorize some stuff about special quadrilaterals, but can you use those skills we talked about back in the first semester? Another one I wanted to talk about is number 3. On the check your understanding within the reading. So here's what we're doing. They're giving us information about describing what the quadrilateral is. Okay, find the values of the variables for the rhombus. Okay, so what do we know about rhombuses? All 4 sides are congruent. So instantly, this side would equal this side if we created an equation. 5a plus 4 equals 3a plus 8. Only because they told us that it was a rhombus. And we know that a rhombus has all 4 sides congruent. So 5a plus 4 equals 3a plus 8. Just got to make sure you know how to solve pretty basic equations. I need to move the 3a to the opposite side, so I subtract. I need to move the 4 to the right side, so subtract again. And you get 2a is equal to 4, divide by 2, a equals 2. So I got those variables. Then I can set these two equal to each other. 3b plus 2 is equal to 4b minus 2. And then you can solve for b. Get rid of the 2's on the right. Get rid of the b's on the left. 4 equals b. Yeah, so we're throwing in a little algebra along with sort of just understanding the new concepts, just kind of committing to memory, what is a kite? What is a trapezoid? What's special about a parallelogram? What's special about a rhombus? Those kind of things. Oh, lastly, they want you to find the length of each side, so all you would do is plug the B variable back in for B and plug the A variable back in for A. They all end up being 14 units of measurement. Okay. So yeah, guys, that's all I really talked about in class. Check out the problem set that's posted in Google Classroom. And just remember, you're using the characteristics that were outlined in these parts of the notes. And a lot of times just looking at the diagrammed way of things, like if they give you variable expressions like that of a kite, you're probably going to be setting up an equation in which this side equals that side, or this side equals that side. So try not to overthink these problems as they come. So, all right, thanks for watching. Good luck on the homework.